Hi everyone, now I'm going to introduce our paper, the Latexify mathematical formula markup revision to assist collaborative editing in math Q&A size. Firstly, I'd like to introduce the background. What is mathematical stack exchange? That is a Q&A site for people studying mathematics at any level and for professionals in related fields. Since its launch in 2010, it contains 1.3 million questions and 1.7 million answers. However, the dramatic growth of posts and users on such Q&A sites poses a severe challenge to the quality assurance for the site content. As for the collaborative editing in that site, to ensure the site quality, Mathematics Exchange encourages users, especially experienced users, to collaboratively edit the post to make them comply with the site quality standard. According to our analysis, among all these posts, nearly half of them have been edited at least once. But there are still some problems with such collaborative editing mechanism. First, it requires significant community effort, especially from high reputation users to edit the post directly and approve the edits by other users. Second, some errors in the original post, especially relatively complicated ones, such as math formula errors or format, are difficult to spot, as they may require a good understanding of the question or the answer content. Third, all these collaborative edits are reactive to existing errors, which may have already harmed the readers of the post before edits, or made it difficult for those who want to help to answer the questions. Now I'm going to talk about the motivation of our work. In addition to collaborative editing for reactive quality assurance, we also need a more proactive mechanism of quality assurance, which could check a post before it is posted, spot the potential issues in the post, and remind the post owner to fix the issues if any. However, different from other Q&A sites such as Quadro and Stack Overflow, there are some domain-specific edits required on mathematical stack exchange. It would require significant manual effort to develop a complete set of rules for representing editing patterns. This challenge motivates us to develop a data-driven deep learning-based generator for recommending post owners or other users potential math-related edits by automatically learning from historical edits. As for the contributions, we conducted an empirical study of collaborative post editing in mathematics stack exchange, including the editing types and the editing content, identifying the need for an edit acceptance tool for mathematics formulae. We developed the MathLatexEdit, a deep learning-based edit acceptance tool that can latexify math expression, revise LaTeX formulas, convert formula screens in mathematics stack exchange to LaTeX sequence for further MathJax rendering to improve the post quality and readability. We evaluated the MathLatexEdit from two perspectives, including the quality of post-edit recommendation based on a larger scale dataset, and the usefulness to assist a wise post editor in editing unfamiliar new posts. This part is the results of collaborative editing analysis. We extracted the topics from users' editing comments to understand their editing content. To extract common editing types, we adopted the LDM model to analyze the post-edit comments. We can see from the table there are some topics that are highly related to the mathematics stack exchange. For instance, the topic 5 is revising mathematical content, and the topic 8 is modifying LaTeX formula, and the topic 4 is converting image. These topics are highly related to the website content. According to our observation, there are three common mathematics domain-specific editing patterns. The first one is changing format, which means actually at first some users will write the mathematical formula as the natural language, and then these users will change the format of the formula into LaTeX. And the second type is correcting mistakes in formula, which means some formula they contain some errors, and the users will revise these errors. And third one is replacing image with latest formula, such as this example. We can see at first the user used the image to show some formula, but these images are blurred and cannot be easily understand. So the user replace this image with the latest formula. The workflow of our approach is as following. Firstly, we extracted the raw post from the mathematics stack exchange, and then we use the encoder and decoder model. The input is the original data, and the output is the modified data. And after training, we use the trained model as a tool to help users to revise the errors in the post. Our model can be divided into textual LaTeX recommendation model and visual LaTeX recommendation model. For the textual LaTeX recommendation model, we only focus on the textual LaTeX revisions. And in this part, we use the transform model. Especially we use inference with sentence normalization in this part. The details are as following. Firstly, we replace some common words as the and some rare words or long tokens into some special tokens. For instance, in here, we replace that as the CW, which means common words, and we replace number with LN, which means long numbers. And in the training part, we keep these special tokens, but after the training, we replace these special tokens into the original words. And for the visual LaTeX recommendation, it can also be divided into part encoder and decoder. In the encoder, we use the image screenshots as input, and we use the testnet and another LSTM as the encoder. And in the decoder part, we use the attention-based LSTM as the decoder, and the output is the converted lattice formula. And for this model, we especially use the inference with image similarity, which means at first, after we got the result from the model, we use the beam search to search for the top 5 formula, and we calculate the image similarity between the original input and the image rendered by this formula, and we sort this formula with the image similarity, and we choose the formula with the highest image similarity as output. This part is the evaluation result of our model. First one is the performance of different methods for the textual LaTexEdit models. We can say our model outperforms the SMT and sequence to sequence in terms of the blue score and green score. And we also evaluate the visual LaTexEdit as the second table. That is the performance of different methods with the synthesized dataset and the real dataset. We can say our model outperforms INFRTY and the WYGIWYS model in terms of the blue score and the image similarity, not only in the synthesized dataset, also in the real dataset. We also conduct an empirical study with our model. We use our model to revise 80 possible edits, and we submit these edits. 88 edits are accepted, and only 2 are rejected. Thank you for listening, and please feel free to contact us for any questions.